Welcome back, students. In this video, we will see the basics of trigonometry and understand the trigonometric ratios. So, we'll be covering the first part of the chapter, trigonometric ratios. So, the entire idea of trigonometry is around one right angle triangle, the relationship between the angles, and the length of the three sides. So, consider this right angle triangle ABC, which is right angled at B, and the other angle is theta, which could be anything like 10 degree, 20, 30, 40, whatever. And the third angle is just only for additional information. This is not required in a subject perspective. The angle at A can be seen as 90 minus theta. How this is arrived is the sum of the angles of a triangle is 180 degree. You know, this is 90, this is theta. So to get the value of this angle A, you need to simply subtract 180 degree minus 90 degree minus theta. That's how you get this 90 minus theta degree. The hypotenuse, that is the longest side, that is just opposite to this 90 degrees. And there is opposite to theta, whatever you see, the length of the triangle or the side of the triangle is called as the opposite side. The adjacent side comes beneath this 90 degree and theta. Whatever comes below 90 and theta is the adjacent side. Now suppose when the position of the theta is changed, instead of here, now you find on the top near A. A is missing here, so you find here near A. In that case, the opposite of this theta, opposite side comes here, and the adjacent side, which is beneath 90 and theta, comes here. This proper understanding is essential to solve most of the problems. And sometimes theta can be given here, sometimes theta could be on the other side. So you just need to understand anything opposite to theta is the opposite side, and anything beneath 90 and theta is the adjacent side. Now let us move on to the trigonometric ratios. These are the ideas which you would have well studied in class 9, but this understanding is the basics for solving most of the problems in this chapter. So we will understand this thoroughly. You need to memorize these formulas properly. Sine theta is, the value of sine theta is opposite side divided by hypotenuse. Opposite side divided by hypotenuse. Opposite side is nothing but length AB, and hypotenuse is nothing but length AC. So that's why I'm going to write it as AB by AC. Similarly, cos theta is equal to adjacent side divided by hypotenuse. So the length of the adjacent side is BC and the length of hypotenuse is AC. So it is BC by AC. Then we have the third ratio, that is tan theta, which is nothing but opposite side divided by adjacent side. So which is AB divided by BC. So you need to understand the ratios, how they are derived, and memorize it properly so that you can apply in your problems. There is one specialty about this tan theta. Tan theta is related to sin theta as well as cos theta. The relationship being sin theta, tan theta is equal to sin theta divided by cos theta. And you know the values of the sin theta and cos theta, which I'm going to substitute here. Upon substituting and solving these values, AB by AC divided by BC by AC, which when it goes up, it becomes inverse. So AB by AC into AC by BC, which on simplification gives you AB by BC, which is what you got in the previous formula approach. So you can see the relationship between sin theta, cos theta and tan theta. Now there is something called as inverse relationship. When you put all the sine theta, cos theta values in inverse, you get some other set of relations. Like 1 by sine theta is cosec theta, which is now what? Hypotenuse divided by opposite side, AC by BC. Then 1 by cos theta is secant theta, which is nothing but hypotenuse divided by adjacent side, that is AC divided by BC. And lastly, you have 1 by tan theta is equal to cot theta, which is nothing but adjacent side divided by opposite side, that is BC by AC. These 6 formulas you should be well versed so that you can solve most of the problems. As in tan, this cot also shares a relationship between sine theta and cos theta. Since cot theta is equal to 1 by tan theta, cot theta is equal to 1 by I'm substituting the value of tan theta, that is tan theta is sine theta by cos theta. When I make it inverse, cot theta becomes cos theta divided by sine theta. There is one important thing to remember, which is very clearly pointed out in your book. Cosec theta, sorry, this should have been theta. Cosec theta is equal to 1 by sine theta, that is the inverse. This should be written as the whole sine theta to the power of minus 1 and not as sine minus 1a. There's a substantial difference. I don't think you'll get any problem out of this, but it's always good to know such nuances. It is there in your textbook. This is called as sine inverse a. This is not same as sine a of power of minus 1. Should there be any situation where you have to represent cosec as 1 by sine theta, which is equal to sine theta power minus 1, be very careful to show sine theta power minus 1 and not this representation. And finally, there is one relationship which is nothing but your Pythagoras theorem. See, these are all lengths of a triangle. AB has one value. When you measure, BC has one value and AB has one value. For a right angle triangle, the square of hypotenuse is equal to sum of square of the adjacent side plus sum of the square of the opposite side. Okay, that is the relationship. Where this will be useful is you will have the value of two of them and you need to find the value of the third one. For example, if you are given the opposite side and adjacent side, you can find the value of the hypotenuse by using this formula. So in summary, trigonometric ratios bring the relationship between the angle theta as well as the length of all these three lines, all these three sides of the triangle. So in the next video, we will try to cover a few problems around this trigonometric ratios. Bye and thank you till then.